My dear students, let me welcome you for this e-learning class. As we discussed in the last episodes, today will be the last part, and which is the magnetism part 6. Up to here the magnetism part 5, and particularly in our the last class, we discussed about the elements of your the magnetic substances. That elements are of your the three types which I have written on your the screen, and that three types are your the inclination, declination and your the horizontal component. And what are its the importance, that also we discussed in our the last class. Those who have not followed that last class, please go through your the YouTube and you can also get your the magnetism part 5. And for the today's class, I hopes that you must have your the preparation and take your the pen and the paper and give at least your the 50 minutes for this concept, and I hopes that you must be clear about the concept which I will give you for its the explanation. And today we are going to discuss the very important things, and that contents are your the tangent law, the concept of your the diamagnetic, paramagnetic and ferromagnetic, which is combinedly known as your the magnetic substances. What are its the properties? Then we will discuss the hysteresis and we will discuss the MCQ, also your the some numericals. So, let us now start and be your the steady and give the attention for this topic. And today we are going to discuss about the tangent law. So, whenever this is a law, it must have your the some statement. And what is that statement? That statement mostly deals with its the tangent, and for your the tangent, whenever it comes, it contains with your the certain angle, and the angle of that angle is nothing but your the p by b as per your the sine and your the cosine of the same angle. And what is this your the tangent law? Before going to know about your the tangent law, let me recapitulate you for your the horizontal component. Horizontal component. So, horizontal means with the horizon, component means one of its the part, that is your the component. As you know in your the scalar vector, the components of the vector, if it is in the plane, it has your the two components, one is the horizontal, one is your the vertical. If it is in the space, it has its the three components, one along your the three axes. So, now we are going to discuss here the horizontal component. So, whenever you will take the two so what are these two? Suppose the name is A, B, C, D, B dash and C dash. What can you guess about your the A, B, C, D? This is one of your the meridian, and that is your the geographical meridian. This is your the magnetic meridian. And one is your the geographical meridian. Geographical meridian. And these are the two fields, the two magnetic fields, when they are taken at your the point which we discussed in the last class, that point is your the A. So, at this point the resultant field of your the magnet or the resultant magnetic intensity, or you can say your the net magnetic intensity is not lying in your the any of its the plane, means not lying in your the horizontal plane, but it lies in this direction, and in that direction it will incline your the certain angle, and that angle is your the del, and that del is what? As we discussed in the last class, there are the two angles we have taken, one is the theta, one is the del. Theta is your the this angle and the del is your the this angle, and the symbolization is depends upon you. For which angle, what type of the symbol you will take, that is your option. but the saying of here the name given to that one must be the same, means its the concept should be the same. If this angle is the theta, this is the angle between your the two meridians, and this angle is your the del. This del is the angle between your the this part with the resultant of this one. Resultant of this one. So, resultant of this one, if this is equals to your the r, then it has your the two components, one is the this one is the this one, means AB is the one component and AD is the one component, and this is its the horizontal, HORI, horizontal component, and this is its the vertical component. So, with the horizontal component, the angle which it makes, that is your the del, and that del with this one, if it is the horizontal one, then we can say that is the horizontal component of your the r, HR will be your the r cos del, and HV will be your the r sin del. So, this r cos del, that is its your the horizontal component. So, for your the tangent law, what it states that if a magnetic needle is taken, suppose this is your the magnetic needle, this one is your the magnetic needle, and this is your the one of the magnetic field, say B1, this another magnetic field of your the B2. When B1 and the B2 be your the two uniform magnetic fields which are present mutually perpendicular to each other, this is the mutually perpendicular to each other, and if a magnetic needle is taken at the mutual perpendicular point, then it will not lie along your the any of that magnetic field, and it to be lie making your the certain angle, making your the certain angle with your the with your the B1, and that angle which it makes, that's tan, means it aligns in this one, this magnetic needle to be your the align in this direction, making your the certain angle theta. The tan of that angle theta is equals to the ratio of that two magnetic fields which we have taken. Means if this is equals to your the theta and draw a perpendicular, this will be your the right angle triangle, then the tan of that angle tan theta will be your the P by your the B. This one is the P which is corresponds for your the B2, and this is your the P, this is the B, B is correspond for your the B1. So, tan theta is equals to your the B2 by your the B1. Though B is your the magnetic field, this is your the magnetic field, it is the ratio of the same two things, therefore, this tan theta has your the no unit in one sense. In the another sense, though this is the theta and we are taking it as the tan of the theta is a particular value, and this is known as your the tangent law. This is your the tangent law. So, by using this tangent law, the horizontal component and your the theta and your the del, when we are going on your the C or on your the AR, by according to that angle which we are getting the command from your the controlling center, according to that one only we are reaching to our the particular point. And if you will take a magnetic needle and according to that one you will move, then after getting to your the point X, you will go to your the point Y. So, this is your the tangents law. And now we are going to discuss another thing, that is known as your the magnetic substances. Magnetic substances. And these three are here the known as the magnetic elements, they are the magnetic substances. So, what are the magnetic substances? Those substances which are affected by external magnetic field, or you can simply say by using the magnetic field. Those substances which are affected by the external magnetic field is known as magnetic substances, and they are of here the three types. So, they are affected by the magnetic field means the affected of here the two types, either it is repel or it is the attract. So, repel or attract. If they are repel and here the attract means it should be of the two types, but it is of the three types, means repel is of the one type and attraction is of the two types. One is the repel, that is your the diamagnetic. This is your the paramagnetic, and this one, another one is your the ferromagnetic. So, these three things we have to discuss: diamagnetic, paramagnetic and your the ferromagnetic. So, have you taken the note? Let me erase it. Let us now first discuss about your the diamagnetic. So, these are the substances. So, what type of here this type of substances, what type of the nature it is showing. So, you know that if it is a substance means it must have, it is made of the matter, it is the made of the matter. The matters have here the atoms, the matter have here the atoms, and if you will go for here the one atoms concept you will take, this is your the nucleus, the electrons to be revolved around it. So, if you will take one of the atoms concept and a electron is moving, I am saying an electron is moving, one electron I am saying. Suppose this electron is moving around the nucleus, this is your the nucleus whose charge is your the Zd. So, due to the motion of the electron, the rate of change of the rate of the flow of the charge is known as the current. So, when the electrons to be the revolve, the current must be developed, and that current and the electrons direction, they are of the opposite. If the electron is moving in this direction, the current to be the move in this direction, and suppose the electron to be move in this direction, then the current to be the move in this direction. If this current to be the continue, then this is your the clockwise, and if this current to be the continue, then that is your the anti-clockwise. And we already discussed in the previous episodes that if the current flow is in your the clockwise, the direction in which the current will move, that is your the south one. If it is the anti-clockwise and the direction in which that anti-clockwise is continuing and the current is flowing towards that direction, the north pole to be the developed. So, if the current is going either in the clockwise or in the anti-clockwise, it will produce a current loop. It will produce a current loop, and if it is the current loop is there, then it will produce here the magnetic moment. It will produce the magnetic moment. If the magnetic moment is there, then it will behave as magnetic dipole. These things we know. Please go through the concept. This is purely the conceptual chapters. There is a derivation chapter, derivation part is the very less. Only if you will go through it very clearly, then once you understand means it will be with you forever. So, this will produce a magnetic dipole. So, when the magnetic dipole to be produced, inside the atoms not only one electron is there. it has your the number of your the electrons. If the number of electrons are there, the number of the magnetic dipoles are there. Suppose this is your the one of the sample which we are saying the diamagnetic, and here we will have the atoms, and these atoms will behave as your the magnetic dipole. Suppose this is the magnetic dipole, they will have the magnetic dipoles. So, dipoles are generally represented by your the arrow marking. So, like by the arrow mark, this is the representation of your the dipole. So, we are giving simply an arrow. So, though it has your the number of your the dipoles and they are in its the different directions. So, one of the dipoles magnetic moment to be your the cancelled with your the another one. Therefore, here the net magnetic moment is 0. The net magnetic moment is your the 0. So, no magnetic moment will be developed there, and the characters due to which it shows is treated as diamagnetic, or the phenomenon in which such characters are developed in that substance, that is known as your the diamagnetic. Means in your the diamagnetic substance, the resultant magnetic dipole moment is your the 0. So, here the resultant dipole moment is your the 0. So, if that resultant dipole moment is the 0, suppose you will go for an example of here the helium. Its configuration is your the 1s2, means one will be near the upward and one for near the downward. So, if they are the pair electrons, then you can say that is your the chemistry concept. If they are the pair ones, then one and the another to be or the cancel each other. So, if for this one we will apply some external magnetic field. Suppose we will act some external magnetic field. So, when some external magnetic field is acting on your the, for which one we are saying the diamagnetic, then what will happen? According to the Lenz law, and if an external magnetic field you are the act, then it will produce your the induced dipole. It will produce your the induced dipole, which is your the Lenz law, you know from the Lenz law. So, what is your the Lenz law? The direction of your the induced one is always opposes which is caused it. Means, as I said in my magnetic effect of the current, I said that son kills father. In this way, I explained before you, son kills father. So, if the son who is the taking bath from your the father, then that son kills your the father. Means, here the induced dipole is developed due to the application of the external magnetic field, because we know that before there is no dipole is present, because one is neutralizes with the others and they are in your the different directions. As I said that the number of the atoms are there, due to the one atom if the dipole moment in this direction, due to the another it may be in the another direction, one is in this direction, another one is opposite direction. So, when the number of the atoms are there, then the dipole moments from one with your the another, that will cancel and the net dipole moment is your the 0. But due to the application of the external magnetic field, the induced dipole being your the developed. The induced dipole which is developed, then what will happen? It will just oppose to it. So, who has given the birth, that's one will try to make affect to your the that original one. Means this induced dipole will your the affect towards the external magnetic field in your the opposite direction. So, if it will act in the opposite direction, then what will happen? There will be a repulsion. Therefore, for your the diamagnetic substance will be treated to that one when that is taken inside your the magnetic field, means the field which we have created, but that substance has no dipole moment. When it is being taken towards your the magnetic field region, at that case, if that to be your the repel, why it is repel? In most of the books it is written that it is the that substances which are repelled by your the magnetic field. Means why it repels? This is its the reason. So, one of the most character of your the diamagnetic is it is your the repel. And what are its the examples? Most of the valuable substances which we are using, like your the silver, gold, copper, your nitrogen at your the STP. Okay. These are your the diamagnetic substance. Means if your silver, gold or the copper, if it will be taken towards the magnetic field, then it will not your the attracted. But instead of taking these, if you will take your the iron or cobalt or the nickel, what you observe? Means they are attracted towards that one. So, what type of the character it shows, that we will discuss now. So, these are the examples of your the diamagnetic substances. Next we will go for your the paramagnetic substances. These paramagnetic substance, that is your the weakly attract, and this is your the strongly attract. This is your the strongly attract. So, whenever we are giving some external field, means the field is given, due to that field inside the substance something is your the developed. So, when something is your the developed means the net intensity of that one, if you will take is your the B, that is proportional to your the sum of your the external and your the internal. Suppose this is your the sample, some external magnetic field is given. So, when the magnetic field is given, that will affect towards that substance, means that substance being your the magnetized by the influence of this one. If this one has its the more power, then what will happen? That substance on which its effect is your the falling, that effect will go on your the increasing. Therefore, the net magnetic intensity will be the sum of the H plus of your the I. H is what? This is your the in the outside, that is your the outside, means which we are providing. I means your the due to that which one is your the developing, that is your the inside one. So, this is called your the intensity of magnetization, intensity of magnetization, and this is your the external field strength. So, if this one will be the more, then this intensity inside one, that will be the more. Therefore, we can say the I is proportional to your the H. If I is proportional to your the H, then I will be the some constant with your the H, and that constant is known as your the kappa according to my pronouns, that is your the kappa. In some books that is written as your the zeta, in some books you will find that is your the chi. So, what are the different names it will be, but this one is your the kappa, and this kappa is your the pronouncement, but it is really known as your the susceptibility. This is the susceptibility. And another thing we know, that is your the permeability. Another one is your the permeability. that is your the mu, it is the ratio of your the B by H, and here the I is the ratio of your the kappa, means kappa is the ratio of your the I by your the H. You see, kappa is the ratio of your the I with your the H. These two are the very important. But what is your the I? Intensity of magnetization. It defined as the ratio of the magnetic dipole moment per volume. This is the ratio of, this is the magnetic dipole moment per volume. So, if it is the magnetic dipole moment per volume, then what will be its the unit? Means this dipole's moment unit by the volume unit, and the dipole moment is equals to the m of your the 12. So, m into 12 means m is the pole strength, that is your the ampere meter, you know, and this is the 12 is the length, that is your the meter. Therefore, this is your the ampere into meter square, and the denominator is your the volume, volume is your the meter cube. So, the unit, I said repeatedly, the unit is purely depends upon its the mathematical expressions. Therefore, mathematical expression is your the m by v. So, m is your the ampere into meter square by v is the volume, volume is equal to the meter cube. So, meter square with meter cube cancel, that is equals to your the ampere by your the meter. So, this is your the ampere meter inverse. So, if we will go in the another way, the questions may also comes, define your the intensity of your the magnetization in terms of the pole strength and the area. So, if in terms of the pole strength and the area will be asked, then what is your the m? Capital M is equals to small m into the 2L, and what is the volume? The concept of the volume is the base area into its the height or the distance or the length. If the area is your the L, then the height or the distance or the length is your the small l. So, this L with the this L is the cancel. So, this is equals to your the m by a. Some may ask me, sir, this you have written as the 2L. I said on that class, 2L means it never you think that it is the twice of the total length. The total length we have taken is the 2L, and if this is the length, this also you can take is your the 2L. Means this length will cancel, only remain here the m by a. M is the pole strength will be how much? That is the ampere into meter. And this is the area, that is the meter square. Meter with meter square cancel. So, this is also your the ampere into meter inverse. You see, this is also ampere into meter inverse, this is also the ampere into meter inverse. So, in which way you will consider? Either it is the ratio of the dipole moment per volume, or you can say it is the ratio of your the pole strength with the area. So, the intensity of a magnetization has its the unit of your the ampere by your the meter, or the ampere into your the meter square. So, if we will go for your the intensity of the magnetization with your the H, as we have written here, I proportional to H, or I is equals to your the kappa of your the H. So, the resultant net intensity, magnetic intensity or flux density beta is the sum of your the external and your the internal, means beta B net is proportional if you will take the equalization of your the H plus of your the I, and that equalization will have your the some constant, that is the mu 0. The question comes, sir, why it is your the mu 0? Mu 0 stands for your the, as I said, permeability of the free space. For the free space, there is no influence of your the external magnetic field. If the external magnetic field is 0, then your the I to be your the 0, because it will not influence to the inside concept of your the that magnetic substance. If I will be your the 0, then B is equals to the constant times of your the H. Though we have taken that is the AR, and for the AR the permeability is your the mu 0. Therefore, B net will be your the B net will be the mu 0 into for the H plus I. But as I know I is equals to the kappa H, let us now substitute that one. So mu 0 is equals to H plus I is equals to the kappa H. So that is equals to mu 0 H is the common, then that is your the 1 plus kappa is equals to your the B net, we are saying the net one. So this mu 0 is the permeability of the free space, that is the constant. Kappa it itself is a constant, constant plus 1, then total 1 is the constant. So this one is your the, with your the mu 0, the total 1 is your the constant, and that total constant is taken here the another mu. So that is the mu m of your the H, where mu m is equals to mu 0 of your the 1 plus of your the kappa. This is your the resultant permeability mu m of your the medium. That medium is equals to your the mu 0 of your the 1 plus H. But we know that B0 is equals to your the mu 0 H, and the relative permeability mu r is equals to mu m by your the mu 0. Relative permeability mu m by your the mu 0. Mu m, you see mu m is equals to mu 0 into 1 plus kappa by your the mu 0. This mu 0 will be the cancel, then that is equals to your the 1 plus of your the kappa. So this 1 plus kappa is equals to your the mu r. So mu r is equals to your the 1 plus kappa. This is the most important relation, and that will lead to distinguish your the diamagnetic, paramagnetic and your the ferromagnetic. So if knowing these relation, now we are going to discuss about your the paramagnetic substance. Next one is your the paramagnetic substance. So in case of the paramagnetic substance, suppose this is your the sample of your the paramagnetic substance. You know a matter has your the number of the atoms, that number of atoms about your the one of the atom, the electrons to your the remove, that electrons when it will remove, then it will produce your the dipoles. So they will produce your the dipoles. Dipoles are there. But as the dipoles are also developed in case of your the diamagnetic substances. But what is your the diamagnetic substance? In case of your the diamagnetic substance, it is shown that the resultant dipole moment is your the 0. Means one of the dipole moment and another dipole moment of your the another atom, if they are in the opposite direction, they are generally your the cancelling. But here it observed that if these are the dipole moments of your the different atoms, but the resultant is not your the 0. Means if you will take a diamagnetic substance, it itself possesses some dipole moments. Means some dipole moments are already existing in that substances, and if some external field to be your the applied as per of your the first one, means for your the diamagnetic external field is applied. When the external field is applied, then what will happen? This external field will make your the dipoles to be aligned in a particular direction. And if the external field is acting towards my the right, those dipoles which are not in the that direction, they will try to align in that direction. Means on this sample, you see this is one of the dipole, it will try to your the align. this is in this direction, it will try to your the align, and you see this is in this direction, it will try to your the align. This is already in that direction, it will remain in that one. You see this is in this direction, it will try to align. But we cannot say that when the magnetic field is applied, all to be or the align along your the that direction, but most of them they will try to align in that direction. Suppose one dipole in the direction, some magnetic field is applied, this magnetic field is acting in this direction, but this dipole is in this, so it will just align in that direction. So most of the atoms they will try to align in the same direction, and already the external field is applied and this is here the given. Then what we will say that the inside the magnetic field will be the more or the less, now it will be the more. So due to that one, they will attract. They will attract. But for the diamagnetic, what happened? There is no dipole moment inside your the substance. When some external field is applied, some induced are there. Here also due to the external field, some induced will be there, but that induced effect is very, very negligible. So this total effect will consider as your the attracting one. So they to be your the attract along your the same direction. So for your the paramagnetic, it will your the attract. And examples are here the aluminum, chromium, alkali metals, etc. These are your the paramagnetic substance. But for your the ferromagnetic, if we have taken a sample, this sample is made in such a way that the resultant dipole moments, when some field to be applied, and that resultant magnetic field per unit volumes or per your the small volumes are of the similar type. Means suppose I will consider it as your the 4 parts. For this part, the dipoles are in this direction. For this part, the dipoles are in this direction, and here it is in this direction, here it is in this direction. These are your the dipole moments it has. For your the paramagnetic, it also has the dipole moments. But what is the difference between this diamagnetic and your the ferromagnetic? In the ferromagnetic, the total dipole moments are divided into your the number of your the sub portions having your the same dipole moment directions to be considered as your the single unit. Means if this is the 1 unit, this is 1 unit, in that units the dipoles, all the dipoles are in the same direction. You see, if here the total sample, the different dipoles have your the different directions, but here they are different, not all are of the same, but in a particular regions they to be the same, and that particular region is known as your the domain. Domain means it will have a some region which is maintained by a particular one, that is called your the domain. The domain of your the Mughals, the domain of your the Portuguese, the domain of your the English portions, means they have their only the importances. So this is the domain, means all are of your in the same direction. This is the domain, all are in the same direction, means in this direction. But in your the sample, the crores of the atoms are there, or the lakhs of the atoms are there. So out of them, the portions in which they are divided of your the different in way. So then after taking this paramagnetic, we have given some external field, and if some external field to be your the applied, suppose this is your the external field I applied. So, previously if you just given your attention, I have given the direction in this way, no mistake. Suppose I given, because here I have given to the right, here I have given to the upward direction. So, what it means? Those domains in which the dipole moments are off in that direction, that dipole moments size will be the enhance or the growth, means here the domain growth will be obtained. Domain growth will be obtained, means this was your the sample, it was of your the 4 parts, here domain growth will be obtained. You see, I have given the direction in this way of the external, and that in this way this domain is directed in that one. So, for that one, that dipole moments to be the grow and the others to be the reduce. So, though this is in this direction, the field is applied, they will try to lean, but not they to be all came immediately. So, these are in this direction. So, they will try to come to that direction. So, this is in this direction, they will try to come in that direction, and this is in this direction, suppose they will try to come in this way. And if another external field, again the external field to be the applied, then these sizes will be the enhanced, and as that sizes to be the enhanced, then what will happen? All these domain parts will be the highly magnetized. So, highly magnetized means they will have the property to attract, but with here the strongly. They to be the attract, but with here the strongly. So, these are here the basic characteristics of here the diamagnetic, paramagnetic and here the ferromagnetic. If this concept is clear to you, then the other properties, what will happen for its the susceptibility, what will happen for its the permeability, then if that magnetic field, that substance to be the placed in the magnetic field, then what will happen? Though these two are here the strongly attracted, means all the magnetic lines of forces of here the external field, they to be the attracted towards that one. This thing we have to here the discuss. So, after knowing the concepts regarding your the diamagnetic, paramagnetic and the ferromagnetic, if we will go to analyze about its the properties in your the for your the note. So, if the question will ask, give the differential properties of the following quantities. So, generally you have to write that differential properties in this way. Suppose what is the difference between your the Rama and Ravana. So, how you will give it the answer? What is the difference between the Rama and Ravana? Means you will make a tabular form. In one you will write your the Rama, and in another type you will write your the Ravana. So, Rama and the Ravana. So, one of one, which one this, who is this, what it makes, like the properties we will write one by one. So, if the question now we will to discuss for your the properties of your the diamagnetic, paramagnetic and your the ferromagnetic, diamagnetic, paramagnetic and your the ferromagnetic, diamagnetic, paramagnetic and here the ferromagnetic. So, likewise we have to distinguish number 1, 2, 3, 4. Similarly, 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 7, likewise the properties will make. So, if we will write in this way your the node, it will be very clear that then what for x, diamagnetic is what, paramagnetic is what, ferromagnetic is what. But most of the students they are writing diamagnetic. So, that is property 1, 2, 3, 4, 5. After writing this, suppose the page is over, then we are switching for the another page. In that page we are writing here the paramagnetic, then 1, 2, 3, 4, 5. But the examiner is not looking within your the very few seconds what you have written the x character for your the diamagnetic, for the paramagnetic and for the ferromagnetic or for the any others one. Therefore, to help for your the examiners, to help for your the evaluators, at that case you have to write in this way. So, not only in your the physics, in your the chemistry, in botany or the zoology, where the differences for the questions will ask, you just make the tabular form. So, let us now put your the attention for your the screen, where I have make your the a property of your the different types for your the dia, para and the ferro. So, what is the diamagnetic substance? As we have discussed in your it is the conceptual form, the diamagnetic substances are those substances which are to be or the repel, and the para that to be or the attract weakly, and for the ferro they to be or the attract weakly. And what are the examples of the diamagnetic substance? Antimony, bismuth, silver, gold, copper, hydrogen, air, argon, these are the different examples. For your the paramagnetic, as I have written, for the aluminium, chromium, alkali, alkaline and the alkaline earth metals, platinum, oxygen, etc. And for the ferromagnetic, the most of them are your the iron, cobalt and your the nickel. The second property is, when placed in a magnetic field, the lines of the force tends to avoid the substance. The lines of force tends to avoid the substance, means if a magnetic substance is taken and this is your a magnetic field, this is your the magnetic field. The lines of force, suppose one is this, the lines of force they will mostly try to go out of that one, out of that magnetic substance. This is your the diamagnetic substance, and the lines of force will go out of that one. Why that is going out of that one? Means though it to be or the repel, means these lines of forces are not to be or the attract towards that one, that is for the diamagnetic. But for your the paramagnetic and the ferromagnetic, what will happen? These lines of forces, suppose this is going your the straight, one of the lines of forces which is coming in this way, that to be or the pass through this one. Suppose another one is will go through this one. Are you clear to my point? The earlier lines of force it is going in this direction for your the diamagnetic, because they are repelling. But here it is the attracting. Suppose it will go in this direction. Suppose another line is here, but that line to be or the attract, but that attraction is your the weakly. Therefore, the less number of the lines of forces will remain in your the air. So, if we look for your the screen, then it is clearly given in your the three different colors for your the dia, for the para and for the ferro. You see, I have drawn the diagram for your the diamagnetic, and just you compare for your the screen. On that screen you have seen that the 4 lines of forces are coming from your the left, 4 lines of forces coming from the left, not 4, the 5 lines of forces are coming from your the left. One is going straight, but the others are going out of that diamagnetic substance. And to the right, just you observe another color with your the same magnetic substance is taken, the 5 lines of forces are coming, but the 3 are inside your the magnet and 2 are of your the outside. And if we go for your the ferromagnetic substance, What is the difference between the paramagnetic substance and the ferromagnetic substance? Ferro is your the strongly attract. So, strongly attract means suppose here this is the one line, this is the one line, this is one line, this is one line, this is one line. So, these 1, 2, 3, 4, 5. So, here we have taken only the 3 are inside. Though it is a strongly attracted, out of the 5 may go through your the that one, but at least your the 4 must pass through your the magnetic substance, because for the dia we have taken your the 3, for your the ferro it must over the more than of your the 3. This is its the second character. The third character, if you will go, when a diamagnetic substance is placed in a uniform magnetic field. You see, the third point is, when a diamagnetic substance or the diamagnetic rod is freely suspended in a uniform magnetic field, it aligns itself in the direction perpendicular to the magnetic field. If the magnetic field is this one and a diamagnetic substance is suspended, then it will remain perpendicularly to that one. But for your the para and the ferro, they to be directed in the same direction. That is your the third property. And if we go for your the fourth or the fifth properties, fourth property is that one, if some liquid shape to be or the taken, if some liquid shape is the taken in your the watch glass and place it over the magnetic field, if the poles of the two fields are the very near to each other, they will look in one case of your the one type and for the two cases of your the similar type. And if we go for your the fifth one, when the diamagnetic substance is placed in a magnetic field, it is weakly magnetized in the direction opposite to your the inducing field, as we discussed. The second one is your the strongly, and the third one will your the more strongly, and the induced dipole moment is very small, in which case we have discussed induced dipole moment for your the diamagnetic, but for the para and your the ferromagnetic substances, they are your the small, but with your the positive in nature, but they are in the negative nature. And if we go for your the kappa, kappa means it is the susceptibility and for the permeability. The susceptibility of the diamagnetic substances, they are the negative and your the very less, but for your the para and your the ferro, they are the positive with your the much more value, but the strongest value for your the kappa is for your the ferromagnetic substance. Therefore, the ferromagnetic substance is always try to keep its the magnetism, and you know that if a strong magnetic field to be the required, then we are taking your the soft iron cores or the iron shafts. That iron shafts are that type of the ferromagnetic which becomes your the easily to be your the magnetized. So, these are the characteristics of your the or the properties of your the dia, para and your the ferromagnetic substances. And the one thing we have to discuss, that is your the hysteresis, and you just remember the hysteresis is nothing but it is a graphical representation with your the B and your the H. And in such a way that the B and H are taken, the B is remain B and H or your the I and H, you can take in your the two different ways, and in both the cases the I or the B is lagging behind of your the H. And in that way we will come to know about its the retentivity and your the coercivity. If we will go for your the higher classes, then you will come to know what are its the quantized concepts. So, my dear students, with this we completed your the magnetism, and in that magnetism you will get some of your the long questions in your the council examinations which are related to that of your the electrostatics. Thank you very much.